We're now going to turn our attention to forward rates. And again, we just did the calculation of spot rates in the last example. Now we're going to do forward rates. And that material again is covered on pages 399 to 403 of the text. Forward rates give us again the interest rates in some future time period. For example, we could look at the forward rate of a bond beginning in period 2 through period 3. They are implied from spot rates, and they're used again with the calculation of spot rates, and again they're forward. They're at an expectation of what interest rates will look like in some future time period. The mathematical notation we will use is given here. Here we're seeing the forward rate between period t and t plus 1. So this could be between 0 and 1, 0 and 2, 0 and 3, 0 and 4. So we could have forward rates averaged over multiple periods, and again it's the expected interest rate between t and t plus 1. And again we're going to imply those from spot rates. In practice, where these forward rates are useful is when determining whether to use a shorter term liability or a longer term liability. You can look at the longer term liability and then look at the forward rates that implies. Compare it to the shorter term liability and see if you're willing to take the risk, if you will, associated with the shorter term liability, having to refinance it versus the rates that are contained within the longer term liability. Here are the three equations for calculating first yield to maturity, zero coupon bond rates, and forward interest rates. In calculating forward rates, we're not going to use the equation for yield to maturity, so let's just eliminate that equation from this slide. And what we're going to use here are the zero coupon bond rate calculation and forward interest rate calculation equations when we solve for our forward interest rates. If you're looking at these equations, note that the C's and M's and P's must equal each other if we're looking at the same bond, and that would imply that the discount factors must also equal each other. If those wouldn't equal each other, then we wouldn't get the same discounted cash flows. That would mean, first off, that our forward rate for period 1 and must equal our spot rate. So these two must equal each other. Those two terms must equal each other. If they didn't, then our discounted cash flows or our bond prices wouldn't equal each other. These two terms must equal each other, or the spot rate for period 2 taken to the power 2 must equal the forward rates taken to 1 times each other. And similarly, these two terms must equal each other. What we're going to do is make use of that equation when we solve these forward rates. Given that, here's what those three equations plus 1 would look like. Equation 1 says our spot rate for period 1 must equal our forward rate for period 1. Equation 2, make sure that our terms on our second period equal one another, or discount factors equal another. Third equation, period 3, and fourth equation, period 4. I put these on there, the fourth equation on there, because we're going to do the example from the previous module, and that had 4 periods in it. The last column, the spot rate column, gives the spot rates from our previous, or the problem that we solved in the previous module. These are the spot rates we solved for. 4% for year 1, 4.51% for year 2, 5.03% for year 3, and 5.57% for year 4. We're going to substitute those into the forward rate equations and then solve our forward rate equations. Here I've substituted the 4% spot rate for period 1 in equation 1, 4.51 spot rate for period 2 into equation 2, 5.03% spot rate into equation 3, and 5.57% spot rate into equation 4. If you're looking at these 4 equations, forward rate 0, 1, or forward rate for period 1 is solved for already. and we know that there's one equation and one unknown for equation 1. We'll solve for that, substitute that into equation 2, then and keep moving down the list of equations. Here we solved for the forward rate of period 1, and you can see that solving in the oval and in the red. So our spot rate of 4% will equal our forward rate, and so our forward rate in period 1 is 4%, the same as the spot rate. You can see that we've then substituted that that spot rate, 4%, or forward rate as well, 4%, into equations 2, 3, and 4 for that term, and we give those in the red in this slide. Given that we now have the forward rate for period 1, we can solve for the forward rate of period 2, and you could solve equation 2, and if you work out that equation, it would work out to 5.02%. You can see that number again in the red and the oval. We then substitute 5.2% into equations 3 and 4, and as you can see, equation 3 now has one unknown into it, and we will solve for the forward rate for period 3 in the next overhead. The forward rate for period 3 works out to be 6.808%. We solve that by solving for the forward rate in using equation 3, working that equation down, and you can see that that's 6.8%. Again, that's in the oval in red, and we substitute 6.8% into the term for the forward rate in period 3 into equation 4. So equation 4 now has one unknown. Equation 4, then you can find out that forward rate for period 4 is 7.21%. And again, we had one unknown in equation 4. Solve it down, you'll find that unknown equals 7.21%. So we began with our forward rates in period 1, equation 1, find it, plug that into equation 2, find the rate for period 2, forward rate, plug the forward rate for period 2 into equations 3 and 4, and then we can solve for the forward rate in period 3, so plug that into equation 4, and solve for the forward rate in period 4. Here is a summary of the forward rates for our example problem. We have a forward rate in period 1 of 4%, the same as the spot rate, of 5.02% in period 2, 6.08% in period 3, 7.21% in period 4. If you're looking at it, our yield to maturities increase, our spot rate are over time, so our yield to maturities run from 4% up to 5.5%. Our spot rates increase from 4% to 5.57%, and our forward rates also increase from 4% to 7.21%. Forward rates tend to increase more than our yield to maturities and our spot rates. So as we're looking at that yield curve, it would imply that interest rates are increasing, and perhaps more than would be implied if you first look at the yield to maturities. To summarize this module, we illustrated how to calculate forward rates from spot rates. Forward rates are expectations rates in the future, and those forward rates are important when you're looking, or when an individual or company is looking at whether to use a short or longer term liability in financing various items.